All right, good morning. Welcome to the beginning of week 3. I wanted to say something about the project groups before we get into the lecture material. Some people have pointed out to me that, and I have been notified by the automated registrar system. There have been a few people who dropped out of the course, and possibly one person who added the course during this last week. And so your groups may have lost a member or two or gained a member. Well, it won't have gained a member. But if your group is no longer what it was, please contact me by email immediately and we'll get things sorted out. I'm probably going to need to reassign one or two people to different existing groups. And I'd really like to try to get that done today or tomorrow, because obviously the first deliverable for the group projects is due on Friday. If I mess around with your group, I can give you another couple of days to meet that first deadline. Any questions before we continue? All right. So we've taken a look now at the fundamental data types that Python provides and also the collection types that Python provides. In this next material, we're going to take a look at different methods of construction of typically collection types, and also what are called Python comprehensions. Well, I'll say something about, I don't know. Comprehensions are considered to be a very cool thing in Python, and I kind of scratch my head and wonder what the big deal is, but whatever. We also need to talk about handling errors, using what are called exceptions, and particularly this is in regard to input from users, because users make, did I forget something? Okay. There we go. Okay. So we're going to talk about construction of collections and also comprehension of collections. We're going to take a look at how to handle errors, which is called exception handling. And in particular, we'll care about this in regard to user input, because when you ask the user for a piece of information, users are notoriously bad at understanding what you asked for, and they will often type stuff that's inappropriate. We're going to take a look at how to define functions. We've looked at decisions and loops and logic and arithmetic, but we need to also talk about how to define functions that you can call. And we're going to see how to organize these things into modules. And then I expect that on Thursday we'll take a look at what's called NumPy, which is an array-oriented, very important library. So far, so good? All right. So you can construct a collection by using the type name of the collection that you want to construct as a function. And in particular, the argument that you give to that function needs to be some kind of iterable. We've already talked about the idea of iterables. Iterables are things that you can step through in a loop. A string is an iterable. A list, a tuple, a set are iterables. A dictionary is an iterable in multiple different ways. You can iterate through the keys, you can iterate through the values, you can iterate through the items. And so if I have, let's say, something like a string, here I've got a string, this is a test, and I use the construction function tuple with that iterable, what happens is I end up getting a tuple containing the one character substrings from that argument string. So let's have a look at that. All right, so let me say, let me create a string. This is test. All right, so whoops, gets. This is test. Forgot my closing quote. Okay, so S is a stir, and if I now say T gets a tuple created from that stir, T now contains the one character substrings from that string in the same order that they are in the string. So far, so good. I can create a set from an iterable by just using the collection name set as a construction function. So let me create set1 as a set from the tuple T. Now sets contain just one copy of the items that you put into it. Of course, this tuple T has a number of T's, it has a number of S's, it has a number of I's, but there's only going to be one copy of each one of those things in the set. So set1 looks like this on my system. Now, recall that items in a set are not ordered, so if you do this on your system, you might get a different order. And in fact, in my example slide here, I do have a different order because I did this on a different development machine at home. All right. Now I can create a list from that set. A set is also an iterable by using the list construction function. And it happens that the items in the list are the same order that they were shown when I displayed the set. That may or may not be the case. What you will know is that if you iterate through the items in a set, you will get all of the items in some order, but you don't know in advance what the order is going to be. And so here I have a list containing those items. Good so far? Now, because a dictionary has key and value pairs as its items, you need something called an iterable over two tuples, or an iterable over pairs, in order to build a dict using the dict construction function. All right, so in this case, SO2 tuples, I'm not going to spell the whole thing out. Okay, so we're going to create a set of two tuples in which the first item in each set will be a string, and the second item, the first item in each tuple will be a string, and the second item in each tuple will be an int. Okay, so SO2T is a set of two tuples. I define them in the order A12, B2, or B22, but for whatever reason, Python chose to represent them, to display them in the opposite order. And if I now say D1 gets a dictionary built from that set of two tuples, the first item in each tuple will be used as the key, and the second item will be used as the value. Okay? Now, it turns out that although the documentation says that you need to have a set of two tuples, you can actually have any iterable over pairs of values. So let me do a different demonstration. Let me create a list, M1, of strings, two-character strings, Okay, so you'll agree with me that M1 is a list, correct? And each item in that list is an iterable that contains two values, correct? So the string AB is an iterable that contains an A and a B. CD is a string that contains a C and a D. And it turns out that if I create a dictionary from M1, that this will work. And for each of these strings of length 2, the first item is used as the key, and the second item is used as the value associated with that key. So although this may look a little, fishy at first, the point is, if you have an iterable, and each of the items in the iterable is a pair of things, whether it's a tuple or a set or a list or a string, you can build a dictionary from that. Okay? Now, the zip function is cool because it takes two separate iterables and zips those iterables together into a sequence of pairs. So if I have, well, I do have ls1. Okay, this has, looks like it's got 7 items in it. We also have an iterable, which is the range function. Okay, so range is another iterable, and here I have generated the sequence of values 0 through 6, that is from 0 up to 1 less than the length of the list of list 1. The zip function allows me to take two iterables, so let's take ls1 and let's take the range of the length of ls1. And what I get from that is an iterable over pairs of values. All right, so I'm going to have an item from ls1, which will be A, and its associated value, which is going to be 0. And then the next item from ls1, which is the space character, and its value, which is 1. And then little e and 2 and so on. Okay, so I have zipped together the values in two iterables of the same length, and from that I've been able to create a dictionary mapping from keys to values. All right. Of course, I could do that the other way around. Let me say D3A is a dictionary created from zipping together the range of len of ls1 and ls1. So here I've put the items in reverse order. So now I have the integers as my keys, and the corresponding strings from the list ls1 as the values associated with those keys. Questions? Alrighty. Yes.
I was wondering, what if we have multiple values for a single key?
Excellent question. And the answer is that okay, what if you have multiple identical values being used as the key when you build a dictionary? It turns out that the last one in the list is going to win. So what if I do this? S gets hello. Actually, I think I already have an S. All right, so let me be, well, I'll use S. Okay, that's fine. So let me create a dictionary D. I already have a D3, right? Yeah, let me create a D. Well, I'm going to call it DA because I may have a D4 coming up. DA is a dictionary built from S and the range of the length of S. Oh, I forgot my zip. So I'm going to zip these together. Okay, so S is my string. This is a test. Range len S is going to be the values from 0 up to 1 less than however long S is. And there are duplicates in this is a test. There are multiple T's, there are multiple I's, there are multiple S's, there are multiple spaces. So here's what happens. I only get one copy of each key. All right, so for the multiple T's, I only get one copy of T as a key. Now, when zip zips this string together with the range, I'm going to get a T and a 0 for the first T, and a T and a 10, I believe, for the second T. All right, if I count over, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's letter sub 10. And this is letter sub 13. So, as I said, the last one wins because T, the key T with value 0 gets created, but then it gets replaced with, but then the value associated with key T gets replaced with 10, and then the value associated with key T gets replaced with 13. So the last one wins. I only have one H, and it is character sub 1. I only have one I, and it is oh no, I'm sorry, I have two I's. So the first one is sub 2, but the second one is sub 5. So for the key I, the 5 wins, and so on. All right? Yes?
So what happens if we do range length of S subtracted by 1?
Length of S subtracted by 1.
As in like not the entire length of S, but we want to do length S and S.
Ah, okay. If you zip together two iterables that are not the same length, that's basically your question, then you will only get however many items are common to both. So if I do something like this, DA2 gets dict, and let me just zip together a string ASDF with another string hi. All right, well, ASDF is four one-character substrings long, and hi is two one-character substrings long. So because of the mismatch, zip is only going to produce an iterable on two pairs, A paired with H and S paired with I, and then the D and the F are just ignored. So DA2 now, if I could type correctly. I'll get it. There we go. All right, so DA2 maps from the A to the H and from the S to the I, and the keys D and F are just not used because they're not paired up by the zip function. Any other questions about this zip function or creating dictionaries? Okay. So we have now used the collection type names as functions to construct collections from. So we can create a list using list, we can create a tuple using tuple, a set using set, a dictionary using dict. A comprehension is another way of building a collection based on using a loop over a sequence of values. And a comprehension is an example of what are called Pythonic things. Now, a Pythonic thing is a nifty thing that you can do in Python, or a nifty way of thinking in Python that's unlike what you can do in other languages, basically. So one trivial example is if I have A equals 12 and b equals 32, and I say a comma b gets b comma a. All right, this is doing what's called multiple assignment. So the current value of b is going to become the value that a refers to, and the current value that a refers to is what's going to be the value that b refers to. In other words, I have switched the values of a and b. I did show you this, right? This is Pythonic. Because it's something that doesn't behave the same way in a lot of other languages. So comprehensions are also Pythonic, and you can think basically that Pythonic is another way of saying that it's really cool. All right. So let's build up to using a comprehension to create a list. Now, if I want a list of all the values between 0 and 15, a brute force way I can do that is to just type them out. Okay, this is interesting. M20. I think I originally had 20 items in this list, and I reduced it to 16 because it didn't fit. But whatever, I'll call it M20. All right, I can just type these things out, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because I'm in square brackets, I can hit the enter key and keep going. 11, 12, 13, 14, 15. All right, well, that was pretty tedious. But fortunately for me, I typed it without making mistakes. And so now I have got what I wanted, which is a list of the sequential values from 0 to 15. It is, though, very easy to make mistakes if you just manually type in a whole sequence of values like this. And what in the world would you do if you needed a list of 10,000 values instead of just 16? Well, so rather than manually typing out all the values, here's a way that's a little better, that requires less typing and is more flexible. I can just create an empty list, and then for I, or the value, the variable of your choice, I'll call this I'll call this George. For George in range of 16, m20.append George. Okay, so George is going to get the value 0 the first time through, then it'll get the value 1 the next time through, and up through the value 15. And so now I have created a list of 16 items. And now it's very clear what I would do if I wanted 10,000 items. All right, I just change the 16 to 10,000 and zip, and it would be done. Well, the Pythonic thing to do is to put the for loop inside of the list rather than having the list.append inside of the for loop. All right, so this notation right here is saying create M20 as a list, square bracket for list, and now instead of George in range 16, append George, I'm just going to say, let me say G for G in range 16. Okay, so here I'm creating a list as indicated by my square brackets, and the items in the list are going to be the sequence of values G for this variable G ranging from 0 up to 15. That is 0 up to 1 less than 16. Okay, so really what's going on here is basically the same as what's going on in this for loop. It's just that we've sort of encloaked the for loop inside of the square brackets. And conceptually what this does really is to make it more clear to somebody reading the code that, oh yeah, the point here is to create a list. The point here is not necessarily to run a for loop. What I want to do is create a list, and I'm using a for loop for that purpose, internally. All right, so the general syntax for a list comprehension is you start out with, well, you have square brackets around the whole thing. And then you have some expression, and it's a sequence of the values of this expression that will be the item values in your list. You must have a for loop then. It is the for loop that makes this thing a comprehension. If you write some notation in square brackets that does not... Oops. It's time for me to feed my dog. But my wife has to do that today. Okay, so if you write some notation that creates a list but you don't have a for loop in there, it is not a comprehension. The for loop is what makes the thing a comprehension. And your for loop uses one or more variables. We haven't seen examples of using multiple variables yet. And it loops through some iterable. In my case, in my specific example, the iterable I used was range 16. But the iterable could be a string, it could be a tuple, it could be a set, it could be whatever. And that's how you build a list with a comprehension. Now, optionally, you can append a sequence of for loops and if tests to add more logic inside your comprehension. So let's see some more examples. Here I'm saying, now for M20 I said, all right, I want the expression for each item in the list to be whatever the current value of the range value is. But if I wanted to create a list of just a whole bunch of zeros, I could say, well, give me 0 for x in range 30, let's say. That's going to give me a list of 30 zeros. Okay, the expression that's going to be evaluated for each item in the list that I'm trying to create is just 0. And so now I have M21 as a list of, M21 is a list of 30 zeros. And I can prove that by asking for its length. All right, so I can have a constant as the value I want for each item in the list. I can have a variable to indicate the value I want for each item in the list. I can even have a computation. So for M22, I'm going to say that I want a list of v squared for v in range 8. Okay, so v is going to take on the values 0 through 7, but my list is going to be a list of the squares of those values. All right, so 0 squared, 1 squared, 2 squared, 3 squared, up through 7 squared. In this next example, I'm asking for each item to be v over 2, where v is ranging from 0 up to including 9, or up to but not including 10. I have added an if test, however. This if test is asking, okay, is the current value of v, which is this value in the range from 0 up to 9, mod 2 equal to 1? What am I looking for there? So if the value is, if the value mod 2 is 1, what is that? Odd numbers, good. So I'm going to get a list of v over 2, but only for odd values of v between 0 and 9 inclusive. All right, so M23 is v over 2 for v in range 10 if v mod 2 is 1. So far, so good. Isn't this cool? This is so Pythonic. My expressions can be very complicated. So here I'm doing a trigonometric calculation, computing cosines. I think I will not type this one in. It's kind of long. But I'm importing my math module as M, and then I'm saying, all right, let me get a list of the cosines of pi times v over 4, where v is going from 0 up to 7. Now, that's basically going around the unit circle in eighths. So, 0 and then pi over 4, pi over 2, 3 pi over 2, 3 pi over 4, pi, and so on. And so I get 1 as the cosine of 0. I get square root of 2 as the cosine of pi over 4. Now, the cosine of 0 should be 0, but I warned you about this before, that often when you're calling math functions, you'll get values that are, like really close to 0. They should be 0, but they're not quite 0, etc. And, as our final example, rather than creating a list of individual items, I can create a list of tuples, or a list of lists, or a list of sets, or a list of dictionaries. By, in this case, I'm creating a list of tuples by enclosing a whole sequence of calculations in a pair of parentheses. This one I do want to type in. So M25 is a list, but each item in the list is going to be a tuple, v to the 1/3 power, v to the 1/2 power, v squared, and v cubed. Okay, so this whole thing is a tuple. And for my for loop, I'm going to say for v in range, 8. Doesn't matter. So now my list is going to contain tuples for powers of 1/3, 1/2, 0, 2, and 3 for all the values between 0 and 7. And you can just glance at that and you know that it's correct. Well, no, maybe not. You see what I'm getting at, though? All right, so comprehensions are very powerful and can be relatively straightforward as far as understanding what the comprehension is trying to do. On the other hand, if you start adding things like if tests and additional for loops and nested stuff, you can write comprehensions that are completely incomprehensible. But they're Pythonic, so they must be good. Yes?
Are comprehensions stored in memory differently than if you just wrote it out normally?
Excellent question. No, let me take that back. When you write a comprehension, it produces an object. It produces a list or a set or a tuple or whatever. But you can I think what you're asking about is what's called a generator function, which you can put a comprehension into a generator function so that no memory gets created until you actually call the generator function. I'm going to punt on getting into details about that. But no, when you execute a comprehension, you are at that moment creating a collection of objects in memory. Yes?
I'm wondering, is it possible to have two variables for the for loop, like a v and
It is. And I'll get to that in a minute when we look at the dictionary comprehension. Okay, so we've looked at list comprehensions, which involve square brackets. Now, a set comprehension is the same as a list comprehension, except you use a pair of curly braces around the the expression and the for loop related to that expression. For a dictionary comprehension, one way of defining a dictionary is to use the colon symbol to separate the key from the value. Okay, so here I've got my for loop is sending k from 0 up to 7, 0 up to 1 less than 8. The key for each item in my dictionary is just going to be that value of k, 0 through 7. And the value associated with each key is going to be k squared. All right, so the key 0 maps to 0 squared. The key 3 maps to 3 squared. Another thing that I can do with a dictionary, though, is let's see. I have no. I've forgotten the names of the variables that I've created. Okay, M1. M1 is this list of strings that are 2 characters long, right? If I want to create a dictionary from the contents of that list of strings that are 2 characters long, I can say, let's say db gets k colon v. No, I'm going to have to say s sub 0 colon s sub 1 for s in M1. And I pressed F1, I guess, by accident. Okay, so S here, as I go through M1, S is going to be a string, and I can ask for the sub 0 item from the string by saying S sub 0, and the sub 1 item from the string by saying S sub 1. Okay, and so now db maps from the first character to the second character. It's easy for me to reverse these, of course. So I can have the second character as the key, and the first character is the value associated with the key. Now, what am I? Okay, I'm trying to answer the question about having 2 variables. Okay, we have done this multiple assignment thing. If I say x comma y gets a comma b, x now refers to 32, y refers to 12. If I set up a list, let me just call it M5, mapping from a list of tuples. Sorry, this is not a very inspired example. I'm just trying to come up with something quickly. Okay, so M5 is now a list on 2 tuples, and if I say DC gets v1 comma v2 v1 colon v2 for v1 comma v2 in M5. There we go, that's what I'm after. Okay, so M5 is my iterable. Each time I get a value from M5, what I'm going to get is a tuple. And I can use sequence unpacking to take the two values in the tuple and assign those values to two different variables. And then I can use v1 as my key and v2 as my value. Okay, so I'm afraid that wasn't very inspired off the top of my head, but I did want to answer the question about, can you have two variables in your for loop? And of course, you can have arbitrarily many variables in your for loop as long as the thing that you're getting values from, each item from there has that same number of values in it. Question?
What is the advantage of using this comprehensions over the normal for loop?
Pardon me?
What is the advantage of using
The advantage. It's Pythonic. It's somewhat unclear to me what the advantage is. I think it's a matter of taste. And in an interview, for sure use comprehensions. Any other questions? Okay. Yeah, I mean, the more intricate these comprehensions get, the more difficult they are to understand what the heck is going on. And so, as I said, it is kind of a matter of taste as far as how you want to go about building your collection. But that is comprehensions. Everybody okay with comprehensions now? All right. Now, next up, we're going to take a look at exceptions. When you run programs, unfortunately, things go wrong. And in Python, there are all kinds of things that will cause an error, which will do what's called raising an exception. In some languages, a lot of these things just would silently fail. But in Python, basically, anytime anything goes wrong, you get an exception. So, for example, if I say 7 over 0, I get this zero division error exception. And if I say open the file asdf.txt, well, there is no such file, at least I hope not. And yeah, so I get told file not found error. And if I try to convert to a float the string 7.6, well, a human would understand that, but Python doesn't, so I get what's called a value error. So all of these, red messages are exceptions. The way to handle exceptions is if you think that some code might fail and generate an exception, you put that code that you fear might fail into something called a try block. And the try block just follows the word try and a colon with a series of indented statements. If an error occurs in that try block, in one of those indented statements in there, then assuming that you have an except underneath your try, the flow of control will transfer to the next statement following except. And you will not get a frightening red error message on your screen, and your program will not die. It will have an option to clean up after itself, assuming that what it's doing inside the except is successful. So let's say I do value equals 123, and then I say I want to try changing val to itself over 0 If that fails, then I want to set val to -1. I'm typing this thing interactively, so what I've typed here looks a little strange. Try I've typed immediately after the shell prompt, except I hit backspace to type it way over at the left edge. That's because I don't have a prompt there. So try and accept are actually at the same indentation level, even though it doesn't look like they are. And the statement within the try and the statement within the accept are also at the same indentation level as each other. So now I'm going to hit the enter key. Cool. I didn't get any frightening red error, but I promise that dividing val by 0 didn't work. If I look at val, I'll see that the exception was triggered and val got set to -1. Okay, whereas if I had just said val gets 123, val gets val divide gets 0, and I had not used try and accept, I just get this angry red error, and if this were part of a program, my program would die at this point. So far so good with the try and accept thing? All right, so let's take a look at a program where we might use this to process and protect ourselves from user errors in a program where we ask the user for some information. We can ask the user for some information by using an input or using the input function. And input takes a prompt as its argument, which is a string. So I'm going to just create a variable called un, and I'm going to call input with a prompt, type some stuff and press enter. Okay, so my prompt is type some stuff and press enter. When I hit the enter key now, the input function is going to be called. It's going to display the prompt, and then the input function is going to pause and wait for me to do what the prompt says, type some stuff and press enter. All right, so the input function is waiting and waiting and waiting and waiting until I eventually say something, howdy. And un is a string containing what I typed. Okay, so the value the input returns is always a string, that is a stir. And it is whatever characters the user typed with the final enter, the final newline character, stripped off. Right, so if I execute the same statement again, and I type 45.678, well, 789. All right, I typed characters representing a floating point number, but input reads those as a string. Good? Now, if what I want from the user is numerical input, I will have to take that string that the input function gives me back and convert it into an int or a float or a bool or whatever type I need it to be. The problem is that conversion can fail. So I'm going to need to do the conversion inside of try with an accept to clean up after the mistake. So let's say I do this. Un gets input, enter your age. Enter your age. 29. I've been 29 for half my life. Enter your age, 29. Okay, cool, 29. And now I want to convert that to a float. Ah, rats. That's an invalid conversion. I get an error. My program would die. So I need to do that inside of a try and accept. And here is a program that combines all this stuff together. It's called UserAge, and it's one of the things that's posted on Canvas in the lecture support files. I think I also posted it as part of an announcement as well. And let's see what this program is doing. Well, we're first initializing a couple of variables. Age bad is true, and age is 0.0. Then we're going to use a while loop because the user may make a whole sequence of mistakes, and we need to keep running this request for the user's age in a loop until eventually the user types something that's correct. So while the age is bad, we're going to do a couple of statements in a try block. We're going to ask the user, enter your age. That input will come into this string variable, age stir. And then we're going to try to convert the age string into an actual floating point number. That's the thing that might fail. If it fails, we're going to yell at the user, as all good programs do, bad age format. All right, so we're going to yell at the user, and we're going to set the age to some nonsense age -1. On the other hand, the user may have typed a correctly formatted age that's ridiculous. We can ask the user, enter your age, and the user might type in -5. Well, nobody has an age of -5. The user also might type in an age like 1, 2, 3, 4. Well, at least so far, nobody is 1,234 years old, right? So even if the user types correctly formatted input, we need to use just plain ordinary logic to check whether the age is outside of a reasonable range. So if the age is not a value that's greater than 0 and less than or equal to 125, we're going to tell the user, hey, you've got to enter a possible human age. And I think current scientific thinking is that even if you don't have diseases or accidents, that the maximum human lifespan is around 120 years. So we're going to assume that medicine has improved a little bit, and we're going to say, all right, if you claim to be greater than 125, sorry, you're a medical miracle, and we don't believe you. Okay, so this is going to keep looping and looping and looping until the user both types something that's recognized as a floating point number, and that floating point number is greater than 0 and less than or equal to 125. Make sense? If both of those things are correct, that it's a valid floating point format and it's in the valid range, then we will set age bad. Come on, mouse. We'll set age bad to false, and at that point our while loop will terminate, and we'll be able to display what the user's age actually is. All right, so let me run this thing. I've got this in a program file, so it's called UserAge. Okay, so this is the program, and if I run this now by typing F5, pressing F5, okay, enter your age. 5011. Bad age format. All right, I get yelled at. And we go back up to the top of the loop. Enter your age. -5. Enter a value between 0 and 125. 1, 2, 3, 4. Enter a value between 0 and 125. So I'm going to say 15.5, and then I accidentally press an A. Bad age format. Okay, so it's just going to keep checking and yelling at you until eventually you type something that's reasonable. All right, well, the program can't tell that I lied, but at least the value I typed is correctly formatted and is an appropriate range. Good? I always tell every website that I was born in 1992. so they don't try to sell me luxury cars. Actually, no, by now they could, I guess. Boy, 1992 doesn't seem long ago to me, but I guess maybe it is. Good. Are we okay with this exception stuff? All right. Yes?
Question. So could you explain how does the syntax work when the user enters a negative number?
Okay. So when the user enters a negative number, all right, so we ask the user, enter your age. The user types like -5. That comes in as a string, a dash character followed by a 5 character. When we convert that to a float, that succeeds, and my age variable now contains floating point -5.0. So the exception is not triggered because the floating point conversion succeeded. And so because the exception is not triggered, and here's where I think I forgot to mention something important. If you don't have an error, then the whole exception part is just skipped over. And we come down here and we test, is the age not between 0 and 125? Okay, well, -5 is not within the range from 0 to 125. And so because the age is not within that range, that whole expression is true, and we display this error message. And because we display that error message, when we get back up to the top of the while loop, age bad is still true. And so we keep looping. Did that help? Any other questions? All right. Well, let's take a look next at how we can define functions of our own. I don't recall. Did I show you defining a really simple function before? I can't remember. Let me do a really simple function. If I say, no, I didn't show you this. I remember I never typed def in your presence. Fun1 x return x over 2. All right, so there is an absolutely trivial function. It's called fun1. You pass it in one value that had better be some kind of number, and what it does is to divide that number by 2 and give you the result back. So if I say fun1 of 9, I get back 4.5. If I say fun1 of 12.2, I get 6.1. If I say fun1 of hello, I get yelled at. Okay, I get an error. All right, so that's a really trivial function definition. Now, in general, the way a function definition works or looks is you start out with the keyword def to indicate that you're defining a function. Then you select the name you want the function to have. The function name can be anything that you could legally use for a variable name. So the first character has to be a letter or an underscore, and then the subsequent characters can be letters or underscores or digits. I like to use underscores to separate words. So here in my little example on the bottom of slide 18, ret underscore pow means I'm going to return a power of some value to some power. Then you can give some arbitrary sequence, some arbitrary number of what are called positional parameters. And these are just named, IJKL, ABCD, age, height, weight, social security number. You can name those positional variables whatever you want. Following all of the positional parameters, you can also optionally have what are called keyword parameters, where the keyword parameter has a name and a default value. We've seen an example of that being used, we just haven't defined such a thing. We've seen that if I say print 1 true hello. All right, those are so-called positional parameters, and they're handed into the print function in order. And what the print function does is to print out each one, and by default they are separated with spaces. But I can use a keyword parameter named sep to change how those values are separated from each other when the values are displayed. So for the print function definition, sep is an example of a keyword parameter. By default, sep is a space character, but we can invoke it by name and use a different string for separating the values. So far, so good? All right, so we can have, when we define a function, we can have our own keyword parameters with default values. And as one really simple little example, here I'm defining this function called retpow. Let me do that live. So I'm going to define, I'm going to, come on, mouse, there we go. I'm going to define ret_pow to have x as a required positional parameter and y as an optional keyword parameter. The default value for y is 2. And all this function is going to do is to compute and return x to the y power. Now, if I call retpow with 5, well, 5 is a positional argument, and it gets passed in and becomes the value of x. And because I only gave one argument, the default value for y is 2, and consequently what this function is going to compute and return is 5 squared is 25. So far, so good. And if I say ret pow 5 3, well, now the variable y is going to have the value 3, and I'm going to get 125 as 5 cubed. If I would like, I can specify a name for either or both. I can specify a name for both of these things. I can say x gets 12 and y gets 2. All right, now here, even though 2 is the default, I have specified what I want y to be. 12 squared is 144. 12 squared is gross. So we have a gross value there. And if you do specify the names of both of the parameters, you can even change the order of these things. So here I'm saying retpow with y equal to 3 and x equal to 4. So that's going to be 64, right? 4 cubed? Yeah, 64. Wow. I've successfully done powers in my head for a matter of minutes. Where you run into problems is if you try to change the orders of the values without specifying a name for x. This, I'm attempting to compute 5 squared, but I'm going to get yelled at because I've specified I've specified a keyword parameter, and I'm following that by a positional argument, and it's a little unclear to me why Python cares, because it should be obvious what to do, but Python gets all upset here and tells me that's an error. Okay? Any questions about this function so far? All right. Okay, so here are similar examples to what I showed you. So retpow expects a specific number of arguments. You can call retpow either with one argument or with two arguments, and that's it. You can't call retpow with 3 or with 0. You have to call it with 1, and optionally you can call it with 2, and that's it. But you can also define what are called variadic functions, which do allow you to pass some varying number of arguments. And you need to use a special argument, parameter, star args, to capture the subsequent positional arguments after the ones that you require. All right, so I'm not sure that what I said makes sense. Let's look at an example. Here I'm defining a function veryFun. And veryFun has 3 required positional arguments. And the parameter names within the function are going to be A, B, and C. Okay, so those positional parameters indicate that I have to pass 3 arguments to veryFun. Now, I may pass more than 3 arguments if I want to. And any additional arguments that I pass will land in this thing called args. And args is going to be a tuple of all those trailing arguments. So let's take a look at this. I'm going to define veryFun. A, B, C, star args. And I'm going to print A, B, C, and args. Now, the star symbol here indicates that args is a varying length thing. And within the body of my function, I can just use args as the name of the tuple containing those additional arguments. So now when I say veryFun, if I only give a couple of values, that's an error, because I have to give at least 3. If I call veryFun with, let's say, 3, 4, 5, 6, 7, well, these first 3 positional values, 3, 4, and 5, are going to become the values of A, B, and C. These trailing ones will create a tuple within this parameter named args. All right, so I've got 3, 4, 5, and then I've got a tuple 6, 7. If I only give exactly 3 values, I'm still going to get a tuple called args, but the tuple is empty. And remember that the way you recognize an empty tuple is with the open and close parentheses. So far, so good. So what could you do to make use of the values stored in this tuple? Well, you can use a loop, for example, to step through the items in the tuple, assuming that the tuple exists. This is a function named mySum, and it turns out, let's see, no. Oh, I know. I ran the UserAge program, which wiped out all of the variables that I created previously. So let me create M using a list comprehension. Cool. Okay, so my list now contains values 2.5, 3.0, 3.5. That is v over 2 for values from 5 through 9 inclusive. And if I ask for the sum of M, sum is a built-in function. Okay, so I already have this function called sum defined. But I'm going to define a mySum function just as an illustration of how you can use the args variable with a loop to step through an arbitrary list of values. So I'm going to define my sum of star args to first just print the tuple, and then I'm going to initialize tote to 0, and I'm going to say for v in args, tote plus gets v. When that's all done, I will return tote. Okay, and that's all that's all there is to that. So when I say my sum with no arguments, I should get back a 0. That's the default if I don't have any arguments. And what did I made a stupid typing mistake. Did you see that? The name of my parameter is args, but I stupidly typed arg here. Nuts. So let me copy and paste this whole thing to where I made the mistake so I can fix that. Args tote plus gets v, and then return tote. All right, so now this should work fine. So if I say my sum with no values, no arguments, I get back a 0. If I say my sum of 1, 2, 3, 4, well, that should give me a total of 10, right? 3 plus 3 plus 4 is 10. And if I say my sum hello 16 2.5, now I'm going to get yelled at. Notice that the tuple does get passed in correctly. All right, so the tuple did get passed in as the string hello, the int 16, and the float 2.5. But then when I try to add 16 to the end of hello, that causes an error. There is no definition for plus gets involving an integer and a string. Okay, so everybody okay with this variable arguments thing, args? Let me show you a cool thing. Because my sum takes a variable number of arguments. In the implementation of my sum, the only operation that we're using in here is plus gets. So the only requirement to be able to use the mySum function is that the arguments that you pass in have to support the plus gets operator. If they support the plus gets operator, then the mySum function will know what to do with them. Consequently, although we think about this as being a tool for adding numbers, all right, so 1 plus 2.3 plus 7 is floating point 10.3. I can actually run my sum if all of the arguments are strings. Okay, because taking a string and doing a plus gets is defined. That's a concatenation. So if all of the arguments are strings, my sum returns to me. What happened? What did I do wrong? Oh, I defined sum as 0 initially. Thank you. Trust me, my example was cool. It just didn't work. But I could have fixed that, right? I could have instead of having sum get 0, I could have checked the data types of the arguments in here. All right, we need to do the next thing, so I'll just move on. All right, well, actually, we only have 1 minute left. So we've looked at a function that takes a variable number of positional arguments using the special *args parameter name. You can also take a variable number of keyword arguments by using the double star notation on a parameter name, and the conventional name that people use for that is KW-args, for keyword arguments. And this is where we'll pick up on Thursday, so I will see you then.